The next skill we're going to work on is solving an equation by factoring. So we'll solve this equation below by factoring and then setting each factor equal to 0. So let's notice that these two terms have a common factor. We could factor out a negative, I'd prefer to do that, negative x squared, which would leave us with an x minus 5, and that equals 0. Now we'll take each of those, negative x squared equals 0, and x minus 5 equals 0. Take those two factors, set them equal to 0. On the left side, we see that x must be 0, because the only number that you could square to get 0 is 0. And on the right side, we see that x equals positive 5, because 5 minus 5 would be 0. So those are the two solutions to our polynomial, that polynomial equation. Next example, solve the equation below by factoring, and then set each factor equal to 0. Well, first thing we would want to do is notice that these three terms do have a greatest common factor. See, we could take out an x squared from all terms, which would leave us with an x squared plus 5x plus 6 equals 0. Now that left-hand side can still factor. We'll have x squared, but that second, that trinomial, should factor as x plus 2 and x plus 3. Now setting each of those equal to 0, x squared equals 0, x plus 2 equals 0, or x plus 3 equals 0, tells us that we have x equals 0 for the first, x equals negative 2 for the second, and x equals negative 3 for the third. So those are the solutions to that polynomial equation. We'll see later that that function, that equation, really could have up to 4 solutions. There are actually only 3 distinct ones. Our last example is going to be we have 4 terms, so factoring by grouping. We go straight to that. Let's look at the first two. We could factor out an x squared. That would leave us with an x minus 3. Now, the second two terms, the second set of terms, could factor out a minus 4, which would leave us with an x minus 3. Now, because we have a common binomial factor, we'll bring that out as x minus 3, and then we're left with x squared minus 4. The product of those equals 0. The second factor there can also, factor. This would be x plus 2 times x minus 2. Now let's set each of these equal to 0. X plus 2 equals 0, x minus 2 equals 0. We have solutions of x equals 3 for the first. That factor was x minus 3. We have a solution of negative 2 for x plus 2 equals 0, and a solution of positive 2 for x minus 2 equals 0. So there are 3 solutions. And notice we have a third degree polynomial. Not a coincidence.